Welcome to this explainer. Look, if you're an educator, you know exactly that feeling, right? Looking out at a sea of completely blank stares. Today, we're tackling a massive, everyday challenge that causes those blank stares: how to stop overloading your students' brains and start truly engaging their minds. We're unlocking the science of words and visuals and looking at how combining them deliberately can absolutely transform your instruction.
Picture this scenario, and yeah, it might feel a little too familiar. You're standing at the front of the room explaining a really complex concept. You're using only your spoken words while a dense, massive paragraph of text sits behind you. Your students might be trying to listen carefully, but after just a few minutes, you can see it happening. They start to glaze over. They lose track. They're frantically trying to write down every single word instead of actually listening to you. The lesson is just completely overloaded with words.
Okay, let's dive into this. Instead of relying on that heavy wall of text, imagine using carefully selected words paired with a meaningful visual. Think about teaching the water cycle. You could use a paragraph with over 100 dense words, but that's linear, meaning a student has to read one word after the other to even begin picturing the whole process in their head. Now compare that to a simple diagram showing the movement of water: evaporation, condensation, precipitation, collection, with short, clear labels. You're instantly communicating continuous flow in a single glance. 100 words will always struggle to do that. This isn't just about making the lesson look prettier. It fundamentally changes how the human mind processes information.
Here's our roadmap for today's explainer. We're starting with the problem of overloaded lessons, then exploring the underlying cognitive science of dual coding, examining our working memory limits, walking through a 5-step design blueprint, and finally, learning why we need to decorate less and represent more.
Let's kick things off with Section 1, Overloaded Lessons, and why exactly those text-heavy lessons fail our learners.
So, the fundamental dynamic we absolutely have to master is this: words explain and visuals represent. When you teach a concept like the water cycle, your spoken words are meant to explain the intricacies of the process. But words are linear, right? They happen one after another. A diagram, however, is simultaneous. You see the entire structure at once. By connecting your linear explanation directly to that simultaneous visual, you're creating a much richer, deeper mental representation than words alone could ever achieve. Together, they lock in understanding.
Moving right along to Section 2, let's look at how this builds into the actual cognitive science behind combining explanations and diagrams.
The psychological foundation behind this approach is just fascinating. Psychologist Alan Pavio developed the theory of dual coding. The core idea here is that human cognition doesn't just have one single funnel for information. Instead, we literally have two separate hard drives in our brain for processing the world. We've got a verbal system and a nonverbal, imagery-based system. When our instruction deliberately combines meaningful explanations with meaningful visuals, we're essentially writing the data to both hard drives at the same time. We give learners more than one way to store and, crucially, later retrieve an idea.
Think of these as two distinct cognitive highways. On one side, you've got the verbal highway, which processes things like speech, written words, narration, and labels. On the other side is the nonverbal highway, completely dedicated to processing images, diagrams, animations, and spatial representations. Now, if you teach using only a massive block of text in your voice, that verbal highway is instantly jammed with bumper-to-bumper traffic, while the nonverbal highway sits completely empty. Dual coding allows us to use both highways evenly, keeping the flow of information moving smoothly.
Now that we understand these two distinct cognitive highways, let's jump to Section 3, because we absolutely need to understand the physical limits of how much information a learner can handle at once. Think of a learner's working memory as a very small mental workspace, kind of like a tiny physical desk. It has a strictly limited capacity. When students encounter way too much information at once, like that massive paragraph of text, that little desk becomes intensely crowded. In fact, it becomes so overflowing that new information is literally just falling off the desk onto the floor. They become cognitively overloaded. And this connects directly to why effective dual coding is a game changer. It helps organize that information into manageable, complementary verbal and visual stacks, clearing up the mental workspace so real thinking can actually happen.
But we must draw a hard line here, because not all visuals are created equal. You always have to ask if a visual actually helps the student think. Take a clear, labeled diagram showing the parts of a cell. That's an incredibly helpful visual.
On the other hand, an attractive photograph of a smiling scientist in a lab, that's an unhelpful visual. Sure, they might have great teeth, but because that photo doesn't actually help explain the structural concept of the cell, it just adds distraction. It clutters up that tiny mental desk rather than adding any actual learning value.
Knowing that we need to organize our students' minds rather than distract them, let's explore Section 4, a practical framework for building these materials.
This 5-step cycle is your daily blueprint for getting this right. First, identify the exact learning goal. Second, pinpoint the difficult concept, the part that's notoriously hard to grasp with words alone. Third, select a visual that actually reveals that underlying structure or process. Fourth, integrate the words and visuals using concise labels, connecting your spoken explanation right to the image. And finally, step 5, make students retrieve and explain it. For instance, if your goal is to teach the parts of a cell, you find the visual that reveals that specific structure, you integrate your labels, explain how they connect, and then, before moving on, you ask the student to explain the cell structure back to you using that same framework. The visual doesn't replace your teaching, it anchors it.
And hey, this framework isn't just for science class, it applies universally. The underlying principle remains exactly the same across the board. Use visual representations to make important, abstract ideas concrete and easy to organize. You can use diagrams and process models in science, number lines and graphs in mathematics, maps in geography. And think about history. By using timelines and visual sequences, you're taking the highly abstract concept of time and giving it a concrete, spatial representation that students can actually see and map out in their minds. In language, you can connect complex vocabulary words with meaningful images and context. It works everywhere.
For our final section today, we really need to shatter a massive myth about what makes a good instructional presentation.
One of the most common fundamental misunderstandings in education is thinking that dual coding just means adding pictures, icons, and animations everywhere. It absolutely doesn't. It is so easy to fall into the clip art trap where we just decorate our materials to make them look fun. You want to strictly avoid overloaded lessons with colorful backgrounds, decorative pictures, unnecessary animations, and excessive text. Remember that tiny mental desk? Those decorative elements just compete for attention and totally overwhelm your students' working memory. Instead, always prefer clean, relevant diagrams, simple models, meaningful images, and incredibly concise labels.
So before you ever add a visual to a lesson, you must treat this as a strict, non-negotiable checklist. Pass it through these 3 golden filter questions. 1. Does this visual actually represent the concept? 2. Does it reduce unnecessary cognitive effort? And 3. Will it help students explain or retrieve the idea later? If the answer to any of these is no, you must remove the visual. Period.
When carefully designed visuals are paired with precise words, learning becomes infinitely more understandable. If you remember only one thing from our time together today, let it be this overarching mantra. Don't decorate learning, represent learning. It is not about making lessons more colorful or entertaining. It's about revealing relationships and hidden structures to build much stronger mental representations for your students.
As we wrap up this explainer, I'll leave you with this final provocative thought to guide your next lesson design. The next time you sit down to create your materials, stop asking yourself, what picture should I add? And start asking yourself, what can I show that will actually help my students understand? Thank you so much for joining me, and happy designing!